So right now we will see some functionality we will going to create with DNA, and then we will going to write the code for ORF and then extract the protein sequence from that one and validate this one with the one of the protein sequence available in NCBI. So we'll be going to design a DNA toolkit. We will be writing the code for the modules, and you can also do the things like colorizing the terminal, which I will tell you how to do this thing. There is one particular site which is very excellent site. You can go through with that one. So before moving to that one, I would like you to introduce one of the best website for the bioinformatician. In order to write your code or verify your code, there is one specific website which is nothing but Rosland. So if you create the account, so I will give you a demonstration of this one a bit. So you need to go register on this site, and after registering on this site, you will get when you do the login, you will get this interface over here. And in this one, the Python village is there, bioinformatics stockhold is there. These two are related to the bioinformatics theoretical part. You can go through with that one. And this is basically algorithmic type of challenges or problems. So the thing is that whenever you are going to solve, suppose I am opening the Python village over here. They are and suppose I am picking one of the problem variable and some arithmetic. So the problem is given over there, and they want some output from you, and they want that in this one they are saying A and B are the side of your right triangle, and they want the length of your hypotenuse. So you can calculate this one based on the data set and earn some point, and thereby you can uh, get a global acknowledgement. Like, do you know about the Hacker Rank and CodeChef, this kind of website for the core info IT or CS guys? There's
Yes,
one
yes.
site, Hacker Rank and CodeChef, and this site is mainly for the bioinformaticians. So you will get a public acknowledgement after doing this one. You will get some badges over there, star over there after solving your problem. So create your account in this one, so that you will get a global acknowledgement of your work. So in this one, the some problems like bioinformatics I like that, like counting DNA sequence, transcribing DNA to RNA, complement that one, some problem related to the recursion. These are different type of problems are there, and you need to do this thing so that you can get more acquainted with the Python as well as the bioinformatics problems. Are you getting the thing? There are multiple
Yes.
problems there. So, in this session, I am just specifying the thing related to DNA toolkit, so that you will be you will have a knowledge about how to write the code, how to import the thing, how to write a module. This kind of thing you will get to know, and based on that, you can do this problem as well as your project problem in your future. So, coming to that one, I am using the PyCharm IDE in order to develop the code. So suppose in this one first, I will start with the random DNA sequence. Uh, then we will slowly move to the real DNA sequence from the NCBI website. So first I need to develop a random DNA sequence. For that one, I am using one of the package from the Python, which is nothing but a random. So I'm importing that one, import random, and I'm taking some nucleotide list, nucleo, nucleotide list over here, so that I can generate a nucleotide from this one. A, maybe it can be T, it can be G, it can be, sorry, it can be your C. ATGC is your nucleotide, and this is nothing but a list. Now I want to generate a random DNA sequence from this one. For that one, I am using a variable random DNA sequence, and from that one I am calling this random function in this fashion dot join, and I'm joining random dot choice nucleotide, and suppose for in range, suppose I want to generate 50 length DNA sequence. So this function, as I already told you, if you gone through with that earlier the earlier slide which I already shared with you, and that that's one of the function of the string is join. And this, if you see this one up to here, here to here, this is nothing but a list comprehension for underscore, because this variable is not utilized by me anymore in this one, so I can use the underscore over there. If you want to use, you can use some variable over there, it is up to you, but I am saying underscore because this whatever the 0 1 2 3 4 value I am getting from this range field, I am not going to use anywhere inside this list. If you see this list, starting parenthesis is over here, sorry, over here, and ending is over here. So what I am doing, from 1 to 50 I am generating a number, and I am saying random, this is a module in the Python. I am saying pick one of a nucleotide randomly from there and create a list. First it is creating a list of 50 nucleotide, and then joining those list elements. If you want to see its output, suppose I'm just removing that join functionality over there, and I want suppose 10 nucleotide. So it will randomly generate 10 nucleotide. If I print this one, print random DNA sequence, if I print this one, you can see, just a minute, a module named, sorry, RA and import, sorry. Now you can see these 10 nucleotide, they are randomly. If I run it again, it will generate some different thing. You can see these are generating random nucleotide over here. So random dot choice will pick one of the element from this nucleotide randomly. For I equal to 0, it will pick the random first nucleotide, then I equal to 1, randomly second nucleotide, now up to the 10. Now after this one, what I am doing this thing, I am supplying all of the list inside a join function, and I am joining this thing without any space. So after this one I will get, this is a random DNA sequence of 10 length. Another one is like that. Are you getting? If I say separator is star over there, so if I say join each character with the help of star, so it will do like that. So between each character there is a star. So I am saying join directly without anything. So it is generating 10 length random DNA sequence. So suppose I want 50 length of DNA sequence. Now it will generate a random length DNA sequence to me of the 50 length. If you see the output over here, this is a 50 length. Again, if I run it again, it will generate maybe some other. Now, earlier one was start from A. Now current one is start from the T. It is a random DNA sequence. Now, based on this, I am just starting with the first problem, like you are over here counting nucleotide. So in this one, how many times A is coming, T is coming, G is coming, C is coming is there. But before writing this one, it may be chance you are downloading the nucleotide sequence from internet, and it may contain some other character apart from A, T, G, C. So you need to validate, first you need to validate that DNA sequence, because we are generating ATGC DNA sequence from our random sequence, which take character either from A, either from T, either from G, either from C. So in this one we will get the DNA sequence only because of these four characters. But when you are downloading the sequence from internet, it may be chance that it may contain some other character like N. Sometimes it do not contain ATGC. Sometimes it contains some other character which is not the part of your nucleotide. So we need to first write a program so that we can validate whatever the sequence on the sequence on which we are doing analysis, whether it is valid or not. For that, I am creating a module DNA toolkit for that one, in which we will going to write all of the functionality of our DNA. So file, I'm naming this file DNA tool kit. So in this one, I'm writing a function def validate. Def validate. I'm supplying a DNA sequence in this one. DNA sequence. If you want to write its doc string, you can write. Suppose I can say check the sequence is valid DNA sequence. So by using this doc string, you can identify what this validate function will do. It will check whether the DNA sequence is valid or not. So first, I will create a library sequence equal to DNA sequence dot. I'm converting that one into the uppercase. If you go through the earlier side, you can come to know that upper is going to convert every character into the uppercase. Upper. Then I am saying for nucleotide in temp sequence, if nucleotide in, now I need to supply this one. So if the nucleotide in ATGC, then it is a valid. So I am saying if nucleotide in this one, it is a valid, then add that nucleotide into the, sorry, if nucleotide is not in this one, then that nucleotide is invalid. Therefore, I can return false. If nucleotide doesn't contain ATGC, apart from ATGC it is containing, then it is not a valid sequence, and then I will say it is an invalid sequence, so I will return a false. Otherwise, I will return temp sequence. So what I am doing in this one, I am saying whatever the DNA sequence you are giving to me, I am first converting that one into the uppercase. Then I am extracting each nucleotide one by one from that one, and I am checking whether that nucleotide is in ATGC or not. If it is not in ATGC, it means it is an invalid sequence. In that case, I will say it is an invalid sequence. That's why I am returning the false. Otherwise, if no character is not like that, that it do not contain apart from ATGC, then that sequence is the valid sequence. So I am returning the temp sequence, which is the uppercase character. For example, if I say in this one, random DNA sequence I am generating, I am writing by my own. For example, I am saying TTGCAATC. So I am writing some small letters, some capital letters, but it will print me the valid sequence. For that one, I need to import this DNA toolkit in my program. So I am importing import DNA toolkit, or either I can say from DNA toolkit import everything. Import everything. Now the function of that one I can use validate this function I am using. So it will return me, because it containing ATGC only, so it will return me ATGC characters in this DNA string in capital form. Just see the output. So it is returning the thing in capital form. I wrote the thing, but it is returning in capital form. But if I something other than this, so just a minute. Uh, I wrote something wrong over there. 10-second nucleotide. If nucleotide not in ATGC return false. Sorry, this need to be over here. Sorry, this need to be over here. Now just see over here. It returned me the false. Otherwise, it returned me everything in the capital case. So what I am doing in this one, because nucleotide, this variable is required here also. This variable is required here also. So I am creating a file which is containing only the structure information. So I am saying Python file structures.py, and I am just saying nucleotide. I am copying from here to here, and in this one I will call from structures structures import everything. Now in this one, if I run this one, this will not throw me an error. Because are you getting why I'm saying it is not throwing me an error? Because I am using the nucleotide variable over here. I am not importing the nucleotide from the structure in this one, but I am importing nucleotide from structure in this one, in DNA toolkit. In structures, I defined a variable nucleotide. In main file, because nucleotide variable is defined in structure file, in order to use this nucleotide field, I need to define from where I am getting this nucleotide. So I need to specify from structure I am getting this nucleotide, but I am not defining over here. Fine. But I defined that I am importing everything from DNA toolkit. DNA toolkit, I am importing everything. And in DNA toolkit, I specified I am importing all of the things from the structures. So whatever I am importing into the DNA toolkit, that is also available in the main. That's why it is not giving me an error. Now, first thing we have checked, the random DNA sequence. Now, based on your first program, in this one, counting the DNA nucleotide. I'm writing a program for counting the DNA nucleotide. So now I will write def count frequency of your sequence, whatever you are providing to me. So I am saying temporary frequency. Initially, the frequency of our ATGC will be 0. So I am using a dictionary. I am saying initially A will be 0, T will be 0, G will be 0, and C will be 0. Now I am saying for nucleotide in my sequence, I am iterating through my sequence. Now I am saying because I already checked this sequence is valid, it only contains ATGC, so I can directly write temp frequency of dictionary of nucleotide plus equal to 1. And at last I will say return temp date. So it will going to count the frequency of my nucleotide. So just check how many times ATGC come in this one. So I will say print formatting of this one. Print frequency of nucleotides. So what is the name of function? Count frequency. Count frequency. And suppose I'm returning this thing in a random DNA sequence. Count frequency in my random DNA sequence. Now if I execute this one, so it will say, if I print this one also, random DNA sequence, print random DNA sequence. So in this random DNA sequence, A comes 8 times, T comes 15 times, G comes 15 times, and C comes 12 times. So if you want to execute this one in this one, so you need to open this one, Rosland, and in this one, it is given that this string is there. So A, C, it is counting A comes 20 times, C comes 12 times, G comes 17 times, and T comes 21 times. So if I execute this one over here, if I give the random sequence in this one, and now I'm going to execute this one. So it will say A comes 20 times. Just a minute. So you can say A comes 20 times, C comes 12 times. So you can verify the thing. C comes 12 times, T comes 21 times, G comes 17 times. Now T comes 21 times, G comes 17 times. Now in order to get certain points, you need to download this data set. So this data set is downloaded. I need to open this one. Everyone will get different data set. So downloaded that data set. Now I am going to execute this code on this downloaded data set. So I copied this one. In that one, I am running this one. So it is saying A comes 218 times. So we need to write the output over there. A comes 218 times. And we need to follow the sequence. Then C, then G, then T. And C comes how many times? C comes 214 times. So C comes 214 times. Then G. I need to write G. G comes 233 times. 233 times. At last T will come. T comes how many times? 246 times. So 246 times. Now I'm going to submit this one. So it is saying that you solve the problem, and after this one it will specify you that you began at this time, you submitted this time, and answer is correct. And if you want to see other solution, you can just click on this one and you will get the solution of other persons who have wrote the code for this one. So it is taking some time. So you can do this by your own. So different persons are giving their own solution. You can check their solution and write your code. So we have created two modules, DNA toolkit structures, and this one is our main file. Now, sometimes you need your output to be in colored form. To be in colored form. For that one, there is a specific site. Just remember this one. You can learn this site, and you can color your text, your code accordingly. For example, one of the code I took from here. I'm just going to copy paste that code, and I'm going to create a one class over here, file Python 5. I'm creating a one module also in this one, utility dot py. In that one, I'm copying that code. Now, if I say in this one, the function is that colored. Just a minute. Function is colored, and you are providing the sequence. It is creating a dictionary first in this one, where it will give some color to it. This is the color code definition. You will get the definition of color, what this color code from that site. And I specified the color code for A, T, G, C, and U also for RNA. And reset color is like that. Now I am generating a string, temp string for nucleotide. Then I am iterating through the sequence nucleotide for each nucleotide. I am checking whether that color is available or not. I am adding that color to my nucleotide. Otherwise, if that nucleotide is not there, I am adding some different color on this one. At last, I am adding the color. This is the white color to my temp str, and it will give me some colors. Just see over here. So I need to call import that module. Import utility from utility import everything. Now in this one I am importing the color color and I am giving this sequence in input. Now you can just see over here, it will get me DNA sequence in colored format. That code you can this meaning of this 033 and this kind of thing you can get access through this site. Now another thing is that we have developed the code for counting the frequency. Now we are going to develop a code related to DNA to RNA conversion. Now everyone know about that. Given a DNA string, we can convert that into the RNA. In that one, thymine is replaced with the uracil. So this process is known as transcription. So I am writing the function from transcription. Transcription. I am providing the sequence to this one, and in this one I can write the definition of function what the transcription is to, but I'm just leaving for a while. I'm just returning sequence dot replace replace t by u. Sorry, u. So when I call this transcription on my DNA, print transcripted sequence. Now I'm saying transcription random. I'm supplying my sequence, and you can see the output of this one. Sorry, this is the bracket over here. I need to put over here. So you can see that T is replaced by U in all over the sequence. So after that, we can write one of the function related to the complement of our DNA sequence. For that one, I am using the complement. Everyone know, because the DNA is not a single strand; it is a double strand. A complement of A is T, complement of T is J, C is G, G is C. So I'm writing a dictionary over here. DNA reverse complement equal to what I'm saying. A complement of A is T. Complement of T is J. A. Complement of G is C and complement of C is G. Yes, so I need to write a function so that I can complement the DNA sequence. How to write this thing of complement? Def complement, you are providing your sequence in input. Then what I need to do? Replace. So if I say something like this, return, just see this one first, join DNA reverse complement nucleotide of this one for nucleotide A sequence. I am just creating a list. This is a list of your complement string. Whenever the nucleotide is A, it will check the complement of the A is. What is the complement of A? It is T. It will put T over there. Similarly, when A will come, it will put T over there. T over there. When T will come, it will put A over there. When C will come, it will put G over there. When G will come, it put C over there. At last, I will get a list, and then after I am going to join that thing with the help of nothing. So if I call this one, print F reverse DNA sequence, sorry, complement DNA sequence, sorry, complement DNA sequence is, if I say reverse, sorry, complement my random DNA sequence, then it will, where I put the thing wrong, okay, it is not accepting that one. Just a minute. DNA toolkit, okay, it's not taking that one. गड़बड़ है join sequence item expected str instant list is form join DNA reverse complement nucleotide for nucleotide in sequence item 0 expected str instance. Just a minute, I need to check this one. Join, right. Oh, I put bracket in this over here. I need to put the bracket over here. This is the list comprehension. Now if I do something, run. So did you get where the problem was? That problem was that because I already told you the list comprehension earlier. So in the list comprehension, we are generating a list. What is the format of the list comprehension? So I already told you the list comprehension is like that. For example, I want list of 10 number. So I will say x for x in range. Suppose I want to generate 10 number. So I need to write this for loop inside the list only. So earlier in that one, what I have done, I put a enclosing bracket over here. That's why that one is giving me an error. So because of that one, I am getting an error. I just removed that one. So the issue was resolved. So it is a complement. Suppose I want the reverse complement of this one. Reverse complement of this one. We have just wrote the complement. I want the reverse complement of this one. So code is very simple actually. I need to copy this one exactly because that one is ultimately returning me a string. And when I say for the string, this one, minus one, the string used to be reverse, yes or no? So I will get the reverse complement of this one. Now I am calling this one over here print. First I am giving the DNA string. I am supposing that I am giving 5 prime to 3 prime. So it will be 5 prime. So 5. So 5 prime. I am saying the colored COL colored random DNA sequence 5 prime to 3 prime. So 3 backslash prime. Now print. I'm writing something over here. Just bear with me for a while. Join. I want this pipe symbol as an output. For to be in double bracket, that's why it is going or in range length of our random length of our random DNA sequence. And now I'm printing 3 prime to 5 prime. 3 prime to 5 prime colored reverse complement of this one. It is just in the colored format. So no reverse complement. It is giving me T to T. No. I think something wrong over there. Yeah, it is returning the minus one. Is the reverse one of this one. Reverse join DNA sequence for nucleotide in sequence, and I am returning minus one. Yes. So reverse complement random DNA sequence is matching with. So I need to put some space over there. First, now reverse complement 3 prime colored random DNA sequence. I'm just doing this thing in comment section. Random DNA sequence is printed. Length of random DNA sequence is there. Reverse complement. Reverse complement is not that one. Just a minute. I called something wrong, I think. So it is more space over there. Now, it is a complement. Sorry, this is the reverse complement actually. Yes, structures DNA toolkit. So it is right actually. So we need to call over here complement only, not the reverse complement, because you know for G, C is the complement, T for A is the complement, like this. Complement trend is like. After that, suppose one of the problem is that I want to count the GC content in my DNA string. Can you please write the code for that one? Counting the GC content in our DNA sequence. In my sequence, I want to count this one. Count the GC content in your DNA string. You can do something like that. Return, because one of the function with the string is that count is a function. So you can directly say sequence dot count. You can say how many times C is there plus sequence dot count how many times G is there, and this will give you number of GC content over your DNA string. But I want how many percentage over there. For that one, what I am doing in this one, I am adding these two things first, then dividing with the length of my sequence, and then all of the expression I multiplied with the 100. So it will tell me percentage of GC content in your DNA string. For example, if I run this one, print GC content in my random DNA sequence is how much. If I run this one, it will tell me the 48% in this one GC content is there. 41% time. Similarly, if I run, because we are generating a random string, sometime it will be 50, sometime it will be 40, 54. The value is changing because we are generating a random DNA sequence in this one. So write another code by your own. If we slide a window, suppose of length 5 or length 4, suppose this is our DNA sequence. So first we will slide 5 length window. So it will be G, A, C, G. First window is like that. In this one, how many GC content is there? Then I will slide a window one step ahead. Then it will contain these 5 sequences, 5 nucleotides. Then in that one, how many nucleotides containing GC percentage you need to calculate. Then again, after this one you need to slide a bit. Then in after this 5 window, how many GC content are there? You need to do like that. What is the basic problem is that now suppose you have a DNA sequence of length 4. Suppose it is made of A, T, G, C. Now I am extracting two size kmer from this one. How many kmers I will able to extract? First 80, second TG, third one is GC. Now suppose my kmer length is my kmer length will be 3 size. 3 size kmer. How many I am able to extract? ATG and TG See, if the camera length is 4, how many substring are able to extract from this one? Only one, ATGC. From this one, you can deduce if the camera length is K or length of the string is N, length of string is N, then how many kmers you are able to generate from a string N minus K plus 1. Now just put the value, it is 4, kmer length is 2, 4 minus 2 plus 1 is how much? 3. So 3 kmers are there. Similarly, 4 minus 3 plus 1 is how much? 2. 2 kmers you are able to take from there. Similarly, 4 minus 4 plus 1 is how much? 1. So 1 kmer you are able to extract that one. So in that one, what you need to do, you need to slide a loop in such a manner it will run up to this much of time, and from each index it will extract the thing in order to extract the thing of 5 length in order to calculate the GC content on each of these schemas. I am writing a function def GC content in my subsequence. I am making a general function. For that, I am taking the sequence in the input. I am saying the kmer length equal to k. I am default. I am assuming the value is 5. From that one, I am extracting the kmer of length 5 from this one. For that, I will take a list. I will take a list result equal to, initially that one is empty. Then I will loop through the sequence for I in range. So up to where it will need to run? From 0, it need to run. It will start from 0. Then length of my sequence minus length of kmer plus 1. First it will start with 0, then for 1, then for 2, like that. Now what I need to extract? Res dot append. I need to extract a sequence from this one. Res dot append. Before that, I will say first temp. I need to extract a sequence from I to I plus k. I need to extract that one. Then I will append this result dot append. So I need to calculate the GC content percentage over there in each of the 5 length sequence or k length sequence. I need to append this one result GC content. I am calling this upper function GC content on this temp. At last I will returning my result. Now I will be calling this one into one of the random DNA sequence. So I will say print GC content and GC content on subsequence. I am giving the random DNA sequence. Random DNA sequence I am giving it into input, and I am saying k equal to 5 of 5 length DNA sequence I want. So it will print me. Now just see over here. It is TATCC. In first one, if you count this one, C is coming 2 times, and 2 divided by 5 is how much? 1, 2, 3, 4, and 5. Just a minute. It is giving it to the 5 over here, and CG, 2 times. 2 GC content. So before choosing this one, suppose I am writing this one over here as a dictionary. So dictionary, I am adding rest of this one time equal to this one, and I am taking a random DNA sequence value. Random DNA sequence equal to, suppose I am giving this one. So now I am running this one. It is saying CGAAT CG2 by 5. 40% this string is came over here. This string, in this string GC contains is 20% of time. In this string the GC contains is 20% of time. In this string GC contains is 20% of time. Got this one? You can write the code something like that. So in this one I am writing the 5 time. So in this one GCATG 60% of time this GC content is there. Similarly, in next substring, 40% of time GC content is there. Like that, it is giving me the answer. Now the next thing is that uh, reading frames. How many reading frames a DNA have? How many reading frames a DNA have? So first I am going to generate a protein from the available DNA sequence. So I am first copying this structure definition because the definition is already given in online mode, and I am copying this DNA codon definition from there. So just a minute. Structures. So this is, everyone know about this thing, that GCT will code for A, GCC will code for A, GCA will code for A, GCC, the triplet of your gene, will code for particular amino acid, on which M is your starting amino acid, the start condition of your amino acid, and whenever you will find dash, then it is the stop codon. Everyone know this thing. So based on this, suppose I want to generate a DNA sequence into the convert, I want to convert DNA sequence into the protein, and that process is nothing but translation. Def trans translation. I am writing the code translate translate sequence LAT translate sequence, and I'm giving the sequence to it. Now I'm converting that DNA into the protein, so I'm returning return DNA codons. I am taking sequence one by one from starting position from 0. Suppose position equal to 0, I am taking position to position plus 3, I am taking. Now for position in range, so position are two times are there. Suppose I am saying this one initial position, init position, or position is range, init, init position. Now length of your sequence, because I am extracting 3 every time, so I need to subtract 2 in this one, and then I extract the 3. Why I am writing 3 over there? Because this 3 will code for one particular amino acid, and next 3 will code for another amino acid. The next 3 will code for another amino acid. Similarly, next 3 will code for another amino acid. So it is generate. Now if I call this function print, uh, what is the name of that function? Translate sequence. Translate translate tre, okay, translate sequence is there, and in that one I am calling random DNA sequence. So it will lead to a protein sequence after this one. So I am getting the error because of, oh yes, so I need to write, because the triplet are coding, so I need to write sequence over there and then one more bracket. So it is generating this amino acid sequence. Got this one? It is taking 3 amino acid first. So check for this one. GTA is there. First codon sequence is GTA. It will code for V. Just check over here. GTA will code for V. Now GTA will code for V, valine amino acid. Similarly, after this one, ATG, this one, next one, this next one, ATG will code for M. ATG, ATG will code for M. So in this way, it is converting this triplet code into the single amino acid. It is taking 3 length substring from the gene, and it is replacing that one with the particular amino acid. Now we know that particular amino acid will start from the M. M is the start of your protein sequence, and dash, whenever the dash will form, it is the stop codon. So in this one we are not getting dash, but in next example we are getting the dash, but we are not getting M. So because these are the random sequence, that's why we are not getting the accurate answer. But when we'll see the original protein sequence, we'll get our correct answer. Now, what I told you, in DNA sequence, there is 6 reading frame. 3 reading frame. Reading frame means whenever the DNA code for the particular protein, the window will slide like that. It will slide for first from here. If I give you the example, just a minute. Suppose this one is our protein sequence, A T T G C A. Suppose this one is our DNA sequence. Now, in order to identify the protein which the this DNA sequence is going to generate, what we programmer do, we will slide a window and slide a window from 1 to 3 for first strand, and we also slide a window from 1 to 3 for complement strand, reverse complement strand. So its reverse complement will be, what is the reverse complement of this one? TAACGT, and the reverse complement of this one TGCAAT. Yes, reverse complement of this one is this one. So whenever ORF, open reading frame, is there, so it will first extract the AT, then GCA. Now second frame it will start. Second frame will start from location number 1, TTG, then CA. So CA is nothing. So it will discard that one. Because the codon need to be 3 length. So over here, for the second portion, TTG is there, but CA we have nothing over there. So CA is not be considered in this one. Similarly, for the opposite one, 3 reading frame for this one, 3 reading frame for this one. Total there are 6 reading frames. So write a code to generate a reading frame for all of these sequences. 6 reading frame for the given DNA sequence and generate the protein from that one. So just see this one over here. This code is there for generating a frames from the DNA sequence. So the code is like that. Just translate sequence, translate sequence. Now what this function is doing is it is taking your protein sequence and it is calling the translate sequence at position number 0. Now at position number 0, what will happen? Just see. Suppose this one is your sequence. At position 0, it will extract the 3 codon from here, 3 codon from here, and convert that one into the amino acid. Similarly, after this one, it is calling it is translating the sequence at first position. So the thing is like that. So it is calling ATTGCA. It is calling TTG and then it is discarding CA because we already wrote this function over here at above translating sequence, converting the DNA sequence to the protein. First we start with 0 position, then we start with 1 position, then we'll start with 2 position. And this one is for the first strand. Now we need to reverse complement for the second strand and generate the amino acid sequence from the second strand also. So just I'm giving one example again in this one. Just run this code one by one for our one example. So suppose our DNA string is something like that. A T T G A. Suppose this one is our DNA string. So what I told you, we need to generate a protein from this one. And we have 6 reading frame, 3 for the given strand and 3 for the reverse complement strand. I am just specifying you how we are generating the 3 strand for given given strand, and you will automatically infer how we are getting the uh, uh, translate sequence for the reverse complement one. So 3 reading frame for this one. So one start from 0, second one will start from 1, and third one will start from 3. Up to here is fine. 3 reading frame for given strand. So one of the strand is given to us. For this one, there are 3 reading frame. One reading frame will start from position number 0, another one will start from position number 1, another one will start from position number 2. Now, what I given over there, I am giving this sequence to input to this generate reading frame function. I am creating a list frames. It is initially an empty list. Now in this one, what I am doing, I am saying first translate the sequence into the protein sequence for the first reading frame. The first reading frame will start from 0. So it will extract 3 of this one, If you go to the translate sequence over here, it will run. It will run initial position. Initial position in this one is 0. So 0 to length of the sequence is how much? In this one, 1, 2, 3, 4, 5. Length of the sequence is 5. 5 minus 2, 3. 5 minus 2 is how much? 3. So it will be extracting, it will be done 0 to 0, 1, 2 times. Yes or no? And
Yes, sir.
each time it will be incremented by 3. So I
Yes, sir.
think I need to tell you the output first. I need you to tell the output first. Just I'm removing this one. So for example, I will take a dummy DNA string first. Random DNA sequence equal to I am saying ATTGA. Now I am going to translate this one. Before this one, I will write this one in another format so that you will get this one easily. So in this time I am not converting into the protein sequence, for example. I am not converting that one into the protein sequence. So I am just calling translate sec in the in the function. So print translate sec, and in this one I need to give random DNA sequence starting with position 0. So I'm just running this one. So it is saying ATT is only there. Why ATT is only there? Just see in this one. ATTGA. We are giving to the function. Yes, this one we are giving to the function. And our loop will run. If you see over here, our loop used to run. Our loop is running position number 0, starting from position number 0 to what is the length of this one? 1, 2, 3, 4, 5. 5 minus 2. And the step size is 3. So it will run 0 to 3 with the step size of 3. So it will first extract sequence because the initial value of position will be 0. So initial value of this position will be 0. So sec 0 plus 3. 0, 0 plus 3. It will extract sequence 0 to 0 plus 3. What is the value of this one? Sec 0 to 3. So it will extract this one ATT. So next step will be next one, the index position will be 3. Yes or no? Because the step size is 3. That's why the next index position will be 3. First index position will be 0. Next index position will be 3. Next sequence will be 3. But this loop is running from 0 to 3 only.
Yes.
That's why third loop will not, third value, this loop value, when 3 will be happen, it will not going to execute. What
Yes,
I
sir.
done over there, I converted whatever the triplet I am getting from there, I converted into the amino acid. So that's why I wrote over there DNA codons. DNA codons to this one. So whenever I will get the triplet, it will convert that one into the particular amino acid. For that codon ATT, what the amino acid is I. So in the main function, I call the random DNA sequence and it will lead to me 6 reading frame. Now I need to call this one generate reading frames. Generate reading frame. It will lead to me 6 reading frames. So first reading frame is up to here, here to here. Second reading frame from here to here. And similarly third, fourth, fifth are there. So if I loop this one for reading frame in this one, print reading frame. So it will give me the 6th reading frame. Sorry, one bracket is there. It will lead me 6th reading frame in the output. First for the given strand and second for the reverse complement strand. Next three will be for reverse complement strand. This one is for our given strand and this one is for our reverse complement strand. Now next function from where you can generate the protein, because this is nothing but what this is nothing but we are getting the amino acid sequence from the protein. Yes or no? We are getting the amino acid sequence from our gene sequence. Now the gene will be encoded whenever we will get M, and gene will encode stop its encoding whenever we will get dash. When the start codon will be inside your gene, which is nothing but the methionine is there, then the coding of your protein will start from the gene. Whenever it will found the stop codon, that is the underscore, then it will stop generation of that particular kind of protein. So I'm writing one another function to generate the protein from the given nucleotide, given amino acid list. So I'm writing the function in this one. Just see over here. Now in this one, I wrote this function. Why it is hopping like this? Now the thing is that what this function is doing, I'm giving one example to you. Suppose A, one of the amino acid is there, and S will be there, M will be there, another one will be the M will be there, फिर K will be there, now suppose G will be there. And after this one, I'm assuming there is a stop codon. So what this function is doing, it is taking your amino acid sequence list and it is first declaring current protein equal to and empty and proteins equal to empty. So current protein initially, current protein will be empty and your proteins will be empty. Now in this one, it is extracting each of this amino acid one by one and checking our condition. Now it will check whether this amino acid is stop codon. No, it is not a stop codon. So it will check whether the amino acid will start from M. So it will first extract the A. So A is not equal to M. That's why this condition will not execute. Now in this one, if this condition is not executed, so the length of your current prod, this current prod will be 0. So this loop will also not execute. Again, it will extract the second amino acid, which is S. So is it stop codon? No, it is not stop codon. It is start with methionine? No, it is not starting with methionine. Again, your current protein value will be length will be 0. So this will not execute. So it is a stop codon? No, it is not a stop codon. It is methionine. Yes, it is methionine. So current prot dot append equal to empty string. We are inserting here empty string. Fine. Now we are running this loop for I in range length of the current protein. What is the length of current protein right now? 1. Yes or no? So this whole thing will convert it into for I in range 1. So only the value for 0th value it is going to execute. Because if I say range 2, it means 0 and 1. If I say range 5, it means 0, 1, 2, 3, 4, 5. Because I already told you over here, I told range 1, it means it will run for 0th value. Now, what I am saying in this one, current prot I value is 0. 0 equal to current prot I plus A. What is our A? A is M. So over here, M will be added to the empty string. After this one, this M will come to the picture. So it is not a stop codon? Yes, it is not a stop codon. So is it equal to the start codon? Yes, it is equal to the start codon. So it will again add a empty string over here. Now it will run for I in range. What is the length of current prot? Now it is 2. So it will run for 0 and 1. So current prot equal to current prot I initially value is 0, equal to current prot plus current prot I, and we are adding the amino acid. In this one, 0th position, we are adding the amino acid. Which amino acid? That current one. So MM will be there. Now, for one, we are executing one index. At one index, this empty string is there. So in this one, M will be added. Now, after this one, the K will come into the picture. Now K is not the stop codon. K is not equal to the methionine, so nothing will be happen there. Now it will run 2 times, and each of these string it will add K. So it will be MMK, it will be MK. After that G will come. G will come. It is not the stop codon. It is not equal to the methionine. So it will run 2 times because the list size is equal to 2. It will add G in this one and G in this one. After that, this underscore will come. Now this is the stop codon. Now it will checking if current prot means if current prot size is greater than 0 or not. Now yes, the current prot size is greater than 0. So you are extracting each protein from current prot and adding to the proteins. Now you have 2 proteins in this one. And after that you are initializing current prot equal to the input. So protein will contain now these 2 things. 2 proteins you are able to generate from this sequence. Because why we are doing this thing? Because after this one, the sequence can be continuous. After this one, maybe A will be there, M will be there, T will be there. Yes or no? Because we are randomly generating a sequence of DNA, and that one can contain multiple underscore over there, multiple stop codon over there. Also in your actual protein, there are multiple stop codons are there. Before after that one, we need to proceed for further. That's why we are adding 2 lists in our program. Now suppose in this one I am giving this protein sequence. We got this protein sequence. We got this protein sequence or reading frame in our output. We are going to give it one by one into our program, and then we will check the outputted protein which is actually generated from this one. Because in this one you can see G is there. So it is not it is before this G, M is not there. So it will not the part of our outputted protein. But this M, R, R, T, N, D, G, E, they will come to the output because start codon is there. But though there is no stop codon, it will add all of those things. Similarly, in this one, it will start from here. No, from here. Add all of those things. Now, suppose I am giving this one as an input to my program. So we have generated the reading frame. Now I am saying print. What is the name of that function? The name of the function is protein from RF. Print protein from, what is the name of that function? That proteins. Sorry, it need to be over there. The proteins from RF, and I'm giving this one as an input, this sequence. So, so because the sequence doesn't contain protein from RF, yes, because the sequence doesn't contain a stop codon in this one, because if the sequence contains the stop codon, it will lead to a protein. Otherwise, it will not lead to us a protein. If I add a stop sequence over here, somewhere here, it will lead to a protein to me. You can just see over here. Now M, R, R, T, N, D, G, E, V, P is there. After that, there is a stop codon. If stop codon is not there, it will not lead to me a protein. So after this one, now I want to generate a protein from whole of my sequence. So I will writing a program. I will leave it to you that you can check by it by your own later. This is your one of the tasks. So it will generate whole of the protein from all reading frame. This is the function, and you can check by your own later. So suppose I'm running this one. Just a minute. Running this one, because from this one we got our all reading frame. We got our all reading frame. Now what I am doing this one, each reading frame I am going to supply to that function in order to get the output. So what I am doing in this one, print, what's the name of that function? All proteins from ORFs. May all protein from ORFs. Random DNA sequence is there. So there is no protein in this one. I'm again running this one. So you can see some of the sequences generating the protein. Some of the sequences generating the protein, but some are not. Now, in order to verify our code, now I'm opening a nucleotide over there, and suppose I am writing the Homo sapiens insulin gene. I'm extracting one of the insulin protein from there. So this one is there, and you can see this one is generating over here. This gene is generating this protein sequence. Now I am giving this file, this gene sequence to the input, and will verify whether our output is matched to the this one or not. So suppose I am copying this one and I am saying our random sequence is like this one. I am generating a protein sequence from this one. Now I need to write it into a correct way for valuing whatever it is generating, print v. Now it is generating these proteins. So out of this one of the sequence must match with the actual protein. So this is over here, our protein is there. That sequence is generating this protein. So I'm copying this one. Now you can see one of the protein is matched. From this DNA sequence, this protein is generated.